Now what we are going to learn is field of view of observer, or field of view of observer, or field of view of observer. What exactly that we are going to learn out here is, suppose there is a mirror. Okay, there are objects 1, object 2 and object 3 in front of a mirror, and these corresponding objects have image 1, image 2 and image 3 in front of a mirror. Okay, irrespective of the size of the mirror, the small mirror or any size of mirror always produces the entire image of the world in front of it. That means it will create an exact virtual world of the, that is the replica of the real world that is in front of it. Now my question out here would be, suppose there is an observer out here. Observer means there is an observer out here. Okay, my question out here is, how much portion of this virtual world this observer can see? For that we learn the field of view of observer. Technique to find out that is, just draw a straight line from the eye to one end of the mirror. Just draw another straight line to another end of the mirror. Okay, and in the virtual realm, in the virtual world, any area that encompasses these two lines, that means this eye or this observer can see anything that lies between in these two planes. Okay, for example, or if I write a remark out here, okay, I'm writing a remark out here. Remark, that means what is the conclusion of this diagram? The observer out here, the observer out here can see the image 1. The observer out here can see the image 1, image 2, but cannot see image number, but cannot see image 3. Okay, in our next slide we'll solve the exact problem that we did sometime before. And our named after topic is minimum length of mirror, minimum length of mirror to see objects, minimum length of mirror to see objects. That means suppose there is a human out here. Remember that 6-foot human or 6-foot tall human example. Okay, suppose a human being is out here and there is a small mirror or any size mirror. Okay, I'll cut down the mirror after I measure it. Okay, my question is, what is the height of the mirror that is required to see his full image? See, irrespective of the height of the mirror, this mirror will form the entire image. Okay, this mirror will form the entire image of him. Okay, at the exact replica. That means if this is eccentric or x distance away from the mirror, this is also x distance away from the mirror. Now my question is, what is the field of view of his eyes? That means if his eyes can see the entire of this, if these eyes can see the entire of this image, that means that is the length of the mirror. So his eyes must see the head. So let's draw one raised to his height. Okay, and his eyes must see the leg. Okay, so that means this much length is the exact length of mirror. Okay, understood this much? Now see, let us tell this length to be y. Okay, now see two triangles. This one is the first triangle. Okay, first triangle, and this one is the second triangle. Okay, let the height of the human be h. The height of the human be h. The height of the human be h. From this first triangle, and this second triangle, can I say these two triangles are similar? Yes. So can I say h divided by y is equals to x, this distance? What is this distance? X plus x, 2x. 2x divided by x. I'm making, or I'm finding the similarities between this triangle and this triangle. Okay. So can I say h by y is equals to 2x divided by x? So out here I'm doing h by y is equals to 2x by x. Okay. Our minimum length of the mirror should be y is equals to h by 2, or we find out the same conclusion as we find out using ray tracing method. Okay. The height of mirror, the height of mirror, sorry, the height of mirror should be the height of mirror should be minimum of half the length half the length of the human half the length of the human or any other object that is scaled. Okay. Half the length of human or any other object. Okay. Now let us do the same problem as we done before. Okay. A human was 6 feet tall. Okay. And there was a mirror. The question is, what should be the length of height of mirror? So this is a 6-foot human, and this is his 6-foot image. Okay. Suppose this is the height of the mirror. Okay. See, from the perspective of point of view of observer, that means this observer should be able to see this entire image. Okay. And we can easily say that before, if this is 6 feet, this should be 3 feet. Okay. That I have derived. But now I want to do something else. I want to do the perspective of field of view of observer from the perspective of image. That means what? That means what is the field of view of this image? That means at what position will the eyes be located so everyone can see his feet. So we draw one ray from this end and the other ray from this end. Okay. That means any person or anyone located at this entire region can see his feet. Now the same question, what portion of the observer can see his head? So we draw one ray from out here and the other ray should be drawn from the other end of the mirror. Okay. That means any person located at this zone can see the head of the person. Now my question is, what percent of people can see both the head and the tail? The percent of people that can see both the head of the tail is nothing but the union of those two areas, and the union of those two areas is this much. See, from the perspective of observer, we draw a straight line towards the total image. From the perspective of image, this entire zone can see the head, this entire zone can see the leg, and the common zone can see both or the entire image. Okay. So our answer should be third. Understood? Okay. See, this observer can see anything in this zone. This leg can be seen by any observer out here. This head can be seen by any observer out here. Okay. And this observer can see everything that is in this zone. Understood? My next topic is effect of rotation of object found by plane mirror. effect of rotation of object formed by a plane mirror. Effect of rotation of object formed by a plane mirror. Okay. Now suppose there is a plane mirror. Suppose there is an object out here. The image will be out here. Image. Okay. This is the object. This is the image. Now suppose I rotate the image by theta degree clockwise. Or theta degree anti-clockwise. So this is the new position of the object. My question is, where will the image be formed? The image will be formed somewhere around here, no? Image 1. The image would be formed somewhere around here. Okay, making a 90 degree with the mirror. Okay. Now my question is, see the mathematical situation out here. Okay, if the object is rotated by theta anti-clockwise, the image is rotated by theta clockwise. Okay, so out here note down the phenomenon. Okay, if the object is rotated theta clockwise, if the object is rotated by theta anti-clockwise, the image gets rotated by theta clockwise. Okay, the image gets rotated by theta clockwise. Now problem is, what do I mean, or what am I trying to tell you, or how do we express this sentence, or how do I express this sentence in mathematical form? See, we know that this rotation is an axial vector. Anti-clockwise means you always use the right hand. Anti-clockwise means towards yourself. Clockwise means away from yourself. Okay, so this anti-clockwise vector is a vector that is towards yourself. So can I say, if displacement of image or angular displacement of object vector is negative of angular displacement of image? Okay, because the object vector will always be opposite to the image vector. Similarly, instead of displacing the object, suppose this object was moving with angular velocity. This object was moving with angular velocity. So similarly, by this relation, we can say angular velocity of object would be minus of angular velocity of image. And similarly, acceleration of object would be negative of acceleration of image. Acceleration of object would be negative of acceleration of image. Okay. Effect of rotation of mirror on an image. Effect of rotation of mirror on an image. So in this topic, what you are going to learn is, see, in the previous example, the object was being rotated. No? So in this example, the object is out here and the image will be formed out here. Same distance. But now, instead of now, our object will be fixed. Okay, object will be fixed. And I'll rotate the mirror in clockwise or anti-clockwise direction. I'll rotate the mirror in or this axis. Suppose I'm rotating the mirror in clockwise or anti-clockwise direction. So what will happen? My new image, okay, a new position of mirror would be somewhat like this. Okay, suppose I rotated the mirror by theta degree clockwise. That means the mirror moved clockwise. This angle is equal to theta. and this angle also is equals to theta if the mirror moves theta degree clockwise. My object position is the same as it is, so this is the same object position. Acha. Now see what will happen to the angle of incidence. My initial angle of incidence was 0. Okay, so the refracted ray traced back to the original path and this become our image. But now for the same object at the same position, my angle of incidence changed by theta. So therefore the reflected ray will also go by theta. Okay, and where will the image be formed? Image will be formed somewhere along this line, a perpendicular normal at same distance. This would be our image. Okay, this would be our image. Let me see if this is x distance from the object or x distance from the mirror. The image should also be x distance from the mirror. Okay, now problem is I'm rotating the mirror by theta degree clockwise. So the normal rotated by theta degree clockwise. Problem is the initial image was out here. Okay, the initial image was out here and this is the image final or image 1. How much degree did this image rotate by? So what is the rotation of this image, or what is the angle of this one versus this one? Achha. What is the angle of this one versus, see, this refracted ray, this reflected ray will trace back the image, Okay, so what is this much angle, or how much is the angle or image rotated by if I rotate the mirror by theta degree? See, this angle is nothing but combination of these two angle by geometry. See, opposite vertices, this two angle becomes this angle, so this is nothing but 2 theta, and the image rotated by 2 theta clockwise. So can I say, can I write down a note? Okay, if the image, if the image is rotated by theta in clockwise direction, the image gets rotated by, the image gets rotated by 2 theta, 2 theta magnitude or 2 theta radians in the same clockwise direction, in the clockwise direction only, clockwise direction only. See out here, you have to note it down or note something out here or observe something out here. If the mirror was fixed, okay, mirror was fixed and I'm rotating the object, okay, when I'm rotating the object, the rotation of image would be opposite to the rotation of object. That means if I'm rotating the object counterclockwise, the image rotation would be clockwise. Okay, but in case I'm rotating the mirror, if I'm rotating the mirror clockwise, the image would be rotated clockwise. The difference is in magnitude. While object is rotated, the image is rotated on the opposite direction but with the same magnitude. But in case of mirror, when the mirror is rotated, the image gets rotated in the same direction but with double the magnitude of the mirror rotation. So if I want to write the same thing in vector form, so can I say theta of image or angular displacement of image is twice of angular displacement of mirror, okay, or omega of image is equals to twice of omega of mirror, okay, or angular acceleration of image is equals to twice of angular acceleration of mirror. Okay, out here there is no minus because the direction of mirror rotation vector is same as the direction of rotation of image vector. Understood? Acha. Now let's look at this question. Okay, a beam of light from a cell is incident normally on a plane mirror fixed at a certain distance x from the source. That means there is a beam of light, okay, or some certain source at distance x from the mirror. Means this is the mirror and the beam of light is x distance from the source. Okay, the beam is reflected back as a spot on a scale placed just above the source L. That means this source is, the name of this source is L. Okay, when the mirror is rotated through small angle theta, that means now what is happening, my source is staying as it is, okay, and the mirror is rotating by small angle theta. Okay, okay, that means my initial position of the mirror was somewhat like this, somehow like this. Okay, my final position of the mirror became somewhat like this. So I rotated the mirror. Initial position of the mirror was like this. I rotated the mirror theta in this direction. So my initial normal or the normal out here or the angle of incidence out here was equals to 0. Why? Because this ray came down, the angle of incidence is 0 and it bounced up. Now what is my angle of incidence out here? My angle of incidence also rotated by theta. Why? Because if I move this mirror clockwise by theta, the normal will also shift by theta, no? And my angle of incidence becomes theta. And law of reflection says that angle of incidence is equals to angle of reflection. So out here my reflected ray becomes this one. So this one is also theta. Now what the question is saying, in a projector screen, this length was measured and this length came out to be y. Okay, and this length is x. Why? Because out here also length is equals to x. Now the question is asking what is the relation between theta, x and y. Okay. In this triangle, in this right angle triangle, can I say tan 2 theta is equals to perpendicular by base, or tan 2 theta is equals to y by x, or tan 2 theta is equals to y by x. Now in mathematics there is a theorem, okay, mathematical theorem. Mathematical theorem. What does the mathematical theorem say? For very small angle, for very small angles, okay, theta is nearly equals to sine theta, which is nearly equals to tan theta. Okay, for very small angles, theta is equals to nearly equals to sine theta, which is nearly equals to tan theta. Now one important thing out here, theta should be in radians. Don't write theta in degrees. That means 15 degrees is equals to sine 15. It is impossible. The value of sine can never be greater than 1. So always write theta in radians. And theta should be more or less, means nearly lesser than 15 degrees. 15 degrees is pi by 12, or less than equals to 15 degrees. 15 to 20 degrees, or less than equals to pi by 12 radians. Okay, understood? So using this theorem, using this mathematical theorem, we are trying to solve this. Okay, can I say if tan 2 theta is equals to 2 theta? Why? Because 2 theta is equals to tan 2 theta is equals to sine 2 theta. is equals to y by x, or theta is equals to y by 2x. So our correct option is option number A. Our next topic is going to be, okay, image formed by image formed by multiple multiple reflection, image formed by multiple reflection by two mirrors, kept at an angle, kept at kept at an angle. Okay, that means what the scenario is saying is that there are two mirrors out here. One mirror is like this and the other mirror is like this. Okay, now suppose there is an object out here. Okay, I am just drawing a circle out here. Why, you'll understand in a little, but for the moment just ignore this side here. I'm drawing a circle out here. Okay, the circle is as follows. Okay, there's an object out here. Where is the image of this object be formed? Somewhere around this line, no? So image 1. Now this object will be reflected out here also. So this image will be formed somewhere out here. Image 1, let this be mirror A, let this be mirror B. So image of mirror, first image of mirror A, this is first image of mirror B. Now see this. First image of mirror A, first image of mirror B. Okay. Now see this image. This first image of mirror B acts as an object for mirror A. Okay, and this first image of mirror A acts as an object for mirror B. So this image of mirror B will be reflected somewhere on the mirror A. It will be reflected somewhere in this line, and our image will be formed out here. So image second on mirror A, and this image, okay, this image of first image of mirror A will act as an object on this mirror B, and will be reflected somewhere around here. Okay, it will be reflected somewhere around here. So image 2 of B. The point that I'm making is, okay, there are few points I'm making by this scenario. The first point is, okay, the reflection will continue. The acha, a mirror will a mirror a mirror will reflect a or mirror will produce an image, will produce an image, produce an image as long as the object is in front of it. That means the object should be in front of it. It doesn't matter the object is real or virtual. See this image formed by mirror A, okay, acts as a virtual object for this mirror B. Okay, so it doesn't care the image is real or, sorry, the object is real or virtual. It will produce an image as long as the object is in front of it. The second point I'll be making out here, all the images formed by this setup formed by this setup. What do I mean by this setup? The setup means two mirrors kept at an angle theta. All the images formed by this setup will lie inside a circle whose center is at point of intersection of mirror. Whose center is at point of intersection of mirror. Okay, understood this much? Okay, now point number 3. Point number 3 is more like objective number 3. In objective number 3, what we are going to calculate or trying to calculate is, see, at certain time this image will again act as an object out here. It will produce some image out here. This will again act as an object out here. Somewhere there will come when the image is behind the mirror and there will be no longer any image. That means the mirror will no longer be able to produce any reflection. Then what you are going to do is you are going to count down all of the images produced by this object. So the number of images formed by this object or by this point object. So our main motto out here is, our main objective that you are going to form out here, or the question that I have out here is, what are the total number of images? What are the total number of images? Okay. So we'll answer this question in the next slide. So for total number of images formed by a mirror, so total number of images formed by two mirrors inclined at each other, formed by two mirrors inclined at each other. Okay, two mirrors inclined at each other. That means there are two mirrors that are, oh, okay, let me write. There are two mirrors, okay, that are inclined at each other, and the angle of inclination of two mirrors is given by theta. Okay, and the object is kept out here. Okay, object. Total number of images will depend upon two things. Okay, if theta is even, theta is, sorry, not theta is even, if 360 by theta is even, okay, then total number of images formed would be 360 by theta minus 1. That means if this was 90-degree, then 360 by theta would be 4, and 4 is a even, then total number of images would be 4 minus 1, which is equals to 3. Okay, if 360 by theta is odd, if 360 by theta is odd, we have further two more cases. Okay, what are the two cases? The angle between the mirrors of theta is such that 360 by theta is odd. The object is kept as symmetry. Symmetry means out here that the object is kept, no? If the line in which the object is kept and is joined with the point of intersection, if that line makes the bisector or angle bisector of the mirror angle, okay, theta by 2, theta by 2, that means this object is kept at symmetry, okay, or object kept at symmetry, symmetry, or perpendicular bisector, sorry, or angular bisector, or angle bisector line, then total number of images would be same as out here, 360 divided by theta by 1, okay. And the second case of out here is if object kept, that means this was a mirror, okay, and the angle between mirrors is theta, such that 360 by theta is odd, and these are our angular bisector. Now if the object is kept not on this line but outside this line, object, suppose object is kept out here, then that means object kept outside symmetry or outside angle bisector line, object kept outside symmetry, symmetrical line, symmetrical line, okay, then the total number of images would be found by 360 by theta, okay. But n is nothing but the total number of images, n is nothing but the total number of images formed, total number of images formed, okay. Okay, now let's read the question. If two mirrors are kept inclined at 60 degrees to each other and a body is placed in the middle, then the total number of images formed is, that means, okay, the number or the angle between the mirrors is 60 degree, okay, then the total number of images is, acha, what is the formula that we learned? See, let's check if 360 divided by theta is even or not. So 360 by theta is equals to 6, even. Then total number of images is equals to 360 divided by theta minus 1, which is equals to 6 minus 1, which is equals to 5. Our option number B is correct. Our next topic is effect of motion of object in front of a plane mirror. In front of a plane mirror. Plane mirror. Okay. What this situation or what I'm trying to say is, or what we're trying to study is, suppose there is a plane mirror and this plane mirror is fixed. Now there is an object. Okay. The image will be formed out here. Now in the earlier cases, we try to rotate the object, no? Try to rotate the object, but in this case, the object will move with velocity. Okay. So suppose the object is moving with velocity parallel to the mirror. So in that case, image will also move with velocity that is parallel to mirror. The velocity of object is VO, velocity of image would be also VI. Out here, VO is equals to VI, or VO vector is equals to VI vector if VO or velocity of object and velocity of image are parallel to the mirror surface, to the mirror surface. Okay, this is case 1. But what happens if out here object is moving towards the mirror, velocity of object, and similarly image, the image would also move towards this side, no? Velocity of image. Out here, velocity of object is equals to minus of velocity of image. Why? Because the vector reverses its direction when v naught and vi are perpendicular to the mirror surface, are perpendicular to the mirror surface. My RR mirror surface. Understood? Okay. I have one more doubt. This velocity of image and velocity of object are with respect to some inertial frame, neither the frame of observer, neither the frame of image. Okay, these all velocities are with respect to some inertial frame. That means some observer sitting on the ground, Okay, in case the question is asking with respect to observer or with respect to object, during that time what you have to do is you have to apply mechanics and subtract out the velocity as taught in your chapter of mechanics. Understood? Now what you're going to study is effect of motion of mirror on the image. Effect of motion of mirror on the image. Okay. In our earlier cases, what was happening? The mirror was fixed and the object was moving around. No, in this case, our object is fixed. Okay, and this is the image, and mirror will be moving around. So the first case is the velocity of mirror is perpendicular to the normal. Okay, the velocity of mirror is perpendicular to the normal. The distance between object and image does not change. Out here, the velocity of object is equals to the velocity of image, which is equals to 0 in case the mirror moves with any velocity, in case the mirror moves with any velocity. Okay, that means what? Even if the mirror is moving, okay, the image of this object will lie out here only. No, the image won't be going anywhere, only the field of view will be changing if the mirror is moving. Okay, the virtual will remain as it is. Understood? Objects move with any velocity along the or perpendicular to the perpendicular to the normal. That means the mirror moves with perpendicular velocity to the normal. Achha. What happens if this is the object, this is the mirror, and this is the image? Okay, the mirror moves in this direction, velocity of mirror. See, after a, suppose let this distance be x, and therefore by mirror formula or image object formula, this distance will also be x. Now the new mirror position is, let us say the mirror shifted by y distance. Okay, mirror shifted by y distance in this direction. What is this much direction? X minus y. This much direction is x minus y. Similarly, this much direction will also be x minus y. Okay, so our new position of image would be out here. Okay, actually it would be out here, but in order to avoid clutter, I'm showing it out here. Okay, now how much distance did the image moved by, or what is the distance from here to here? If we calculate x plus x minus x minus y minus x minus y, we get this distance as 2y. See, calculate and check it. So from our calculation, if the mirror moved by y distance, the image is moving by 2y distance. Okay, if the mirror moved by y distance, the image is moving by 2y distance, and it is along the direction of movement of mirror. Okay, in case of object, it was what? The velocity of object was opposite to the direction of, or the velocity of object was opposite to the direction of velocity of mirror. Out here what will happen is velocity of image is minus of velocity of object. Oh, I made a wrong statement. Velocity of image is twice the velocity of mirror if velocity of mirror of mirror is along the normal line. Okay, the velocity of mirror is along the normal line, and these relations of velocity are also valid for displacement and acceleration. Okay,